Hi, this is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. Today, in our video lecture series, we are going to discuss about the review of WBG, that is wide bandgap semiconductor technology, advantages and disadvantages, which comes under the WBG devices and their application in the real world first unit. So, come, let's get into the topic. So, silicon carbide and gallium nitride, that is GaN, SiC, are typically representative of wide bandgap semiconductor materials, which is also known as the third generation semiconductor materials. Compared with the conventional semiconductor silicon Si or gallium arsenide GaAs, wide bandgap semiconductor has the wide bandgap, high saturated drift velocity, high critical breakdown field, and other advantages. It is highly desirable semiconductor material applied under the case of high power, high temperature, high frequency anti-radiation environment. Widely used of semiconductor technology in various military fields broke the traditional concept formed in thousands of years that weapons equipment's advantages is only the size, the number and more massive destruction, so that the system of weapons becomes smaller, lighter, less power wasted, higher reliable, stronger, operational, effective, and powerful. Military electronic equipment required to operate at high temperature, high radiation, and other harsh environments can detect small targets of long distance and real-time process of high-speed sensor data and the operating frequency in the band beyond the ordinary commercial range. The require of military electronic equipment of for semiconductor components is much higher than ordinary electronic equipment. Its safety and reliability of components must be higher. It is worth noting that the using conventional semiconductor technology to produce electronic system has been unable to meet the requirements of next generation military applications of for volume, weight, and high reliability. Wide bandgap semiconductor devices has advantages of high frequency, high power, high temperature, and potentials of resistance to harsh environments, so that they provides a method to solve these problems. Semiconductor bandgap greater than 2.2 electron volt is defined as the wide bandgap semiconductor, that's a WBGS, typically of wide bandgap semiconductor materials or silicon carbide SiC and gallium nitride. These semiconductor materials are also known as the third generation semiconductor material. In comparison with silicon and gallium arsenide, as the representative of second generation of semiconductors, wide bandgap semiconductor has merits of wide bandgap, high saturated drift velocity, higher critical breakdown electric field. In order to highlight the advantages compared to Si and gallium arsenide as the representative of the second generation semiconductors, United States was the first country to start the wide bandgap semiconductor technology research, and many well-known universities and research institutions such as Raytheon, Triquent, BAE, MIT, Cree put a lot of manpower and material resources in technology, and their research is most outstanding. DARPA, that's a Defense Advanced Research Project Agency in 2002, lasted 8 years, divided into three stages. The first phase from 2002 to 2004 focused on material development, achieved commercialization of 2 to 4 inches SiC substrate material has been completed. The second phase from 2005 to 2007 focused on device development, used wide bandgap semiconductor material to product and demonstrate the RF power amplifier for improving its power added rate, bandwidth, and power density. Ultimately, achieved high volume production of high reliability, high performance microwave and millimeter wave gallium nitride based devices. This third stage from 2008 to 2009 developed gallium nitride based high reliable, high performance MMIC monolithic microwave interrupt circuit, and tested their application in the number of modules. This program cost $100 millions. 6-inch silicon carbide crystal and single crystal substrate is shown in this slide. So, with the support of DARPA, Raytheon achieved the world advanced level in the wide bandgap technical field, such as the first GaN MMIC produced by Raytheon. So, Raytheon is the company, US defense contractor and industry cooperating with the manufacturing concentration in weapons and military and commercial electronics. The Triken Semiconductor is the leader of gallium-nitride hemp developed field with the highest level of technology in the development of gallium-nitride alternative substrates. S-band and X-band GaN MMIC application has achieved excellent system performance. System simulation results show that with a wide bandgap semiconductor SiC replacing Si, many system parameters have been greatly improved. So wide bandgap devices for the radar application is shown in this diagram. SiC power modules developed by Cree will be extensively used on the new aircraft of US Air Force F-35 Lightning II. So F-35's radar and the SiC power components. So this is ACOM power devices. Germany developed gallium nitride HEMT devices, high temperature module. The SiC device of Infineon company, this one. And this is Grippen's active electronically scanned array radar system. So advantages. So the WBG results in the high breakdown voltage so that the device can be operated at high voltage. Power electronics always prefer high breakdown voltage semiconductors. Excellent thermal stability enables device based on WBG material to operate at high temperature. WBG semiconductor in general are thermally stable when compared to the SI, GE and GAS. High critical electric field strength of WBG semiconductor results in low on-state resistance, hence conduction losses can be reduced. The disadvantages are WBG semiconductor are in general very difficult to grow up to larger diameters in the size due to issues involved in the growth. Most of the WBG semiconductors are leaky and it is difficult to make them semi-insulating due to issues related to the doping and growth. Power electronics always prefer semiconductors with a low leakage current to increase device lifetime. Few WBG materials such as gallium nitride exhibits poor thermal conductivity when compared to the Si and other WBG like SiC. Power electronic devices prefer high thermal conductivity WBG materials so that the heat can be dissipated easily due to this operation. Thank you.